I have the clock face that we created open, and we're going to be working on cam. But first, I want to make some additions to this clock face. After milling apart, the sharp edges can have small burrs on them or be very sharp, both of which can cut you. However, we can remove those when we milled apart, simply by chamfering the edges. So I'm going to add those chamfers to the model. I click Modify, Chamfer, select these edges, and put in a distance of 20 thousandths of an inch. Okay. Now moving to the back of the clock face, Modify, Chamfer, select these edges. I'm also going to select these edges. And use the same 20 thousandths of an inch. If you zoom in here, you can see that we're just going to knock off those edges so that they're not sharp anymore. All right, if we were doing a thorough job of cam, we would model the mill table, the mill vise, any fixturing, all the tool holders, have all that information in the cam process in an assembly so that we could check for problems such as crashing the machine, running the tool holder into the vise, or that sort of thing. For this exercise, we're not going to go that in depth. We're going to keep things very simple. Here is our model of the clock face. First thing I want to do is go up here, click on Model, and come down to Manufacture. Up at the top here we have the various manufacturing options that we can use. The first thing I need to do is make a new setup. So I'm going to click Setup, New Setup. Now it is assuming that this clock face is going to be made out of a piece of material. So let's look here, and that's what you see in the yellow. Let's look over here at the setup. The operation is milling, and it's assigned a work coordinate system. We have a z-axis that is pointing up out of the face, a y-axis pointing in this direction, and an x-axis pointing in this direction. And that is what we want when we mill this side of the face. However, we're going to start by milling the back of the face. The reason for that is that milling the back, we're just going to have this a rectangle of 1/4 inch thick aluminum clamped in the vise on the mill. And we'll drill a hole through the center and mill out this pocket and mill these chamfers. Then when we flip it over, we will use this center hole to bolt this square of aluminum to a fixture that will fit inside this cutout for the clockworks. That will provide a fairly stable fixturing so that we can cut the circular clock face out of the square piece of material. But that means that we don't want to start on this side. We want to start on the other side. So we're going to have to take care of that work coordinate system. But first I want to look at the stock. It's using a relative size box. I want to use a fixed size box. The model position I do still want to have in the center. The box width is not going to be 130 millimeters, it's going to be 6 inches. Depth is also going to be 6 inches. And the height is going to be 0.25 inches. I'm going to go back to setup here in a little bit, but first I'd like to get out of working in millimeters. I'm going to click OK here. I'm going to come over here to units, millimeters, edit that, and change it to inches. Now I'm going to come back to setup 1 and edit it. Here in the work coordinate system, we need to switch things around so that Z is positive coming up out of the back of this face. I'm going to select Z-axis, plane, and Y-axis. Here I can select the Z-axis. I'm going to zoom in, select that, and then flip that axis. So the Z is now pointed in the direction we want, but X and Y are flipped. So I'm going to select the X-axis, zoom in, and well, zooming in doesn't help. Select that axis and flip the X-axis. Now we have what we want. Z is pointing up out of the back of the material in the clock face. X is positive to the right, and Y is positive away from us. Now, if I had entered the fixture, if I had this in an assembly, I could define that here, but I'm not adding that step. I'm going to go ahead and click OK. And we have setup 1 complete. So let's go ahead and work on setup 2. Come up to setup, new setup, setup 2. The axes are actually how we want them, so I'm just going to change the stock. Instead of a relative size box, we're going to go with a fixed size box. 6 inches by 6 inches by 0.25 inches. Okay, setup 2 is complete. Let's go ahead now and build our tool library. The CNC machine will use several different tools to mill this part. And the CAM software needs to know what those tools are. So I'm going to go to Manage, Tool Library. Here's where you can add a tool holder, a lathe tool, laser, and so on. We would only be on the mill working with tools and tool holders normally, and I'm going to skip the tool holders just to make this simpler. Over here in libraries, I have several different ones. I'm going to click on the part I'm working on and click plus tool. All right, the first tool I'm going to be putting in is an end mill. It's not a ball end mill. If I drop down this, it is a flat end mill. It does have 3 flutes. The diameter is 3/8 of an inch. The flute length and shoulder length, I'm just going to leave as they are. The material is not high-speed steel, it's carbide. There is no through coolant. Clockwise spin rotation. I'm going to go to feeds and speeds. I'm going to set the spindle speed to 2,300 RPM and the cutting feed rate to 15 inches per minute. The lead in, lead out of 15, ramp and plunge of 5 inches per minute are fine. And then in post-processor, this is tool number 3. Okay. Now for the next new tool. Under post-processor, this tool number is 29. For the cutter, this is a drill. The diameter is 5/16. It has 2 flutes. It is high-speed steel. Feeds and speeds, I'm going to put this at 2,000 RPM. I'm going to give this a plunge feed rate of 10 inches per minute. And OK. For the next tool, this is tool number 53. It is a drill mill. I don't have that option, but I'm going to use chamfer mill. You can see here is the very tip diameter. That is essentially nothing. So I'm going to put 0.0001 inches. The diameter is 1/4 of an inch, and the angle is 45 degrees. Feeds and speeds, I'm going to put 5,200 with a cutting feed rate of 15. That doesn't give a whole lot of feed per tooth, especially since back here under cutter I forgot this is not a 3 flute, it's a 2 flute, and the material is carbide. So back to feeds and speeds. Not a whole lot per tooth, but that will likely give a decent surface finish for this tool. New tool. This is tool number 61. Feeds and speeds 2,300. I'm going to go over to cutter for a minute. This is a 1 flute tool. Come back here and change this to 15. You can see that this is taking a fairly hefty chip, 6.5 thousandths thick, but this tool can do that. This tool is also not in this list, but I'm going to use a face mill to approximate it. It has a diameter of 3/4 of an inch. And I'm going to give a shaft diameter of 3/4 of an inch also. The tips on here are carbide. This is roughly what it looks like. Want to make sure that this flute length is more than 1/10 of an inch. And it is. So cutter, feeds and speeds, got the tool number. Okay. The other tool I want to put in here is number 64. Feeds and speeds 2,000. And this will change. Let me designate the cutter type as a center drill. It has a diameter here of 3/8 of an inch. The rest of this can stay as it is. It's not exactly what it looks like, but it's close enough. I'm going to give it 2 flutes. It is high-speed steel. And we're going to slow these down somewhat, not that we're going to use them. And a plunge, which we're going to use, a plunge feed rate of 5 inches per minute is fine. Click OK. Add a tool. This tool number is 70. On the cutter, this is a drill. It is 2 flutes, high-speed steel. The diameter is 0.1065 inches. We'll leave the rest of this as it is. Feeds and speeds. I'm going to leave this at 5,000, but the feed rate I'm going to cut to 10. Click OK. Then we need to add another tool, and its number is 71. And it is a tap, right hand. It is 2 flutes, clockwise rotation, high-speed steel. The diameter is 0.138. This is for a 632 screw, so it's 32 threads per inch. Hopefully this thing can do fractions. 1 divided by 32 gives you the thread pitch. Feeds and speeds, I want to be running the spindle at 400 RPM to do this. And OK. All right, I think these are all the tools I need for this part. If not, I'll fix it later. And I'll X out of this. So now let's go back and select Setup 1. And we're going to add our first operation. So I want to start by either drilling this hole or machining this pocket. Either one of those is fine. However, drilling is one of the fastest ways to remove material. So I'm going to start by drilling. So if I come up here, select drilling and drill, the first thing I need to do is select the tool. Now before I drill a hole, I need to use a center drill, which is a very rigid tool to start that hole. If you just start with the drill bit can wander and get going crooked and do a very bad job drilling the hole or break off. So you want to start with a center drill. And click OK. You can see I've got my spindle speed of 2,000 RPM, plunge feed rate 5 inches per minute. I want to check that before moving on to geometry. It needs to know what I want to drill. So I'm going to select the hole faces by zooming in and clicking on that. Now we've got the different heights. So you can see I've got a clearance height here of 0.6 inches. I'm going to change that to 1 inch. I've got a retract height of 0.2 inches. I'm going to leave that alone. I've got a top height of 0 inches, but I'm not going from the whole top. I'm going from the surface of this part. So I'm going to set that to model top. Now this is just the center drill, so I'm not drilling all the way through. I'm just making a little peck at the top to get the drill bit centered. So I'm going to switch this to model top. And let's try minus 0.1. 0.1 inches deep. That should work just fine. Then on cycle, I'm going to go with full retract. Here I have a peck depth of 94 thousandths. I'm going to change that to 0.05 with no dwell and click OK. Now I can right click on this operation and click simulate. And I'm going to select to show the stock and then play what's going to happen. It's going to come down, make a couple pecks, and it's done. That is what I want it to do. Alright, the next operation is going to be nearly identical. We have a little peck in the top of the center drill ready to drill the hole. So let's select our 5/16 drill bit. Here it is, number 29. Okay. 2000 RPM, that's good. Here, the whole face. I'm going to select this again. And let's go to our heights. Clearance height, I'm going to change that to 1. Again, retract height 0.2 is fine. Feed height of 0.2 is fine for now. Hole top, the top height, I don't want hole top. I want the model top. And here, instead of hole bottom, I want model bottom. And I want to look at this to make sure that this drill bit comes all the way through. Let's try minus 0.2 inches. That's plenty. Let's try minus 0.1. That might not quite be enough. So I'm going to go minus 0.13. That looks pretty good to me. Next, let's go with cycle. And I'm definitely going to go with deep drilling, full retract on this. And the peck depth of 78 thousandths is fine. Now I'm going to click OK. So now with drill 1, we have used a center drill to start drilling this hole. Then we've used our 5/16 drill bit to finish drilling that hole. And now we need to make this pocket. So for the pocket, I'm going to go to 2D adaptive clearing. I'm going to select this 3/4 inch. Here it's called a face mill. The tool is actually called a shear hog, but that's the tool we want. I'm going to click OK. 2300 RPM. That's good. So pocket selection. This is the pocket we want. I'm going to select in there. And heights. I'm going to put this clearance height of 1. I'm going to leave the retract height of 0.2. The top height is the stock top. The bottom height is the selected contours. I'm going to move on to passes. Tolerance is fine. The optimal load is fine. I'm not going to turn both ways on. Climb milling. Stock to leave. I'm going to change this to 0 for both. Radial and axial. I also want to use multiple depths. Maximum roughing step, I want to decrease this to, let's go with 0.08. In linking, pretty sure I have all this the way I want it, and I'm going to click OK. So here it's developed a toolpath, and I can see that this toolpath doesn't come in and clear out these corners, and I need that to happen. So something needs to change. I go back and edit this. Minimum cutting radius, I'm going to change this to 0.001. Click OK. And now it's coming in and clearing out these corners. And you can see by looking at these tool paths, we've got two different cutting depths, which is good. That will reduce the load on the machine a bit. Just a reminder, you should be saving this periodically. Now I want to come in and put in a 2D chamfer. I'm going to select, it's a chamfer mill here, what we're using to fudge a mill drill, and click OK. You can see this thing is spinning fairly quickly and moving fairly slowly. Now we need to select geometry, and this is important. On this contour selection, if I zoom way in here, you can see that I have this line on the chamfer, this line on the chamfer, and this imaginary line where the edge of the material would be before the chamfer happened. The way I have gotten this to work is by selecting this line. I'm sure there's other ways. I'm going to put in my retract height up 1 inch and leave the rest of this as it is. And then in here, with the chamfer width, I'm going to put that at 0, and the tip offset I'm going to put at 0.03 or 30 thousandths, and click OK. Now, just to make sure this is in fact doing what I want to do, I'm going to right click on it, click Simulate, and I want to see the stock, and I want that stock to be transparent. I'm going to go ahead and play this simulation, and let me zoom in here to make sure what I want is happening. Yes, I want the tip of this to be offset from the side a little bit while that comes around. So that simulation looks good. I'm going to close this and put in another 2D chamfer. Now select the tool. Now it already had chamfer mill in there. Good geometry. Now I'm going to come in and grab this line. Same 1 inch here, leaving that the same. And here I'm going to do the same 0 and 0.03 or 30 thousandths, and click OK. And let's simulate this. If I zoom way in here, you can see, yes, that this is also working out the way I wanted it to. So I'm happy with that simulation. All right, I had a bit of a time figuring out how to chamfer this hole in here. I'm not sure if I was missing something simple or if the software is having difficulty with that. In any event, what I finally did was use Trace. It does have the tool that I want in here. And I'm going to select, if I zoom way in, not this line on the outside, but this line on the inside. The clearance height, I'm going to put at 1 inch. And everything else I'm going to leave. And with that, I get a tool path, which isn't ideal. It just goes right on the inside of this. It should actually be at that location, plus or minus the tolerance of the mill, which is a couple of thousandths of an inch. So that should work fairly well.